Hello, I'm going to talk about consistent hashing, a common pattern used during the system design interviews. So I'm going to cover what it is, its usage and benefits, some extensions like virtual nodes, and integrations with systems. So what it is, suppose n is a number of hash values we want to get, and then we define m for some number of slots, and m should be sufficiently large, ideally like noticeably more than n square. We can just pick some number like 2 in power 31 or 2 in power 63. So we put slots on the ring like in the circle. So like after like m minus 1 there goes 0. And then for every hash value I, we have a node on this circle, and we generate some pseudo-random number hk, where h0, h1 and so on is like a sorted order of those. So then to compute a hash of the input s, we map it to a certain number x from 0 to m minus 1, maybe like using some simple hash function like with modulo. And then we find next hk so that it's greater or equal than x, but more than hk minus 1. And there is one edge case where it's like if it's h0 and n minus 1, then we can go over the this like boundary between like 0 and m minus 1. But basically we like find the next item on the circle, which is like in clockwise order comparing to x. Like here, for example. Yeah, we go from x, find hk, and k is our consistent hash of s. So what are the usages and benefits? So the problem it's helping to solve is reduced number of rehashing needed when like number of hash values n changes. And for modulo hash, like some function from s modulo n, almost all the values would change their hash if n changes. So why would that be a problem? So it's bad for this case of mapping a key to some service instance that should process it, for example, cache or a database. Like imagine which like one node goes down or like one instance goes down, and like now suddenly like you don't have mapping anymore because like almost all the values would be on like different instances comparing to what hash function offers. So consistent hashing helps with that by redistributing only some values as which are adjacent to added or removed hash value. If a node is added, then only a small part of a ring would start mapping to the new node, because only like those values which are between like a node which is in between the like new node and its adjacent nodes, so only those values might be affected. And if you remove a node, then similarly, like the values which are like being mapped to that node, they would now start being mapped to the next node on the ring. So let's talk about virtual nodes. So while this approach is nice and like it can reduce number of rehashing to like 1 divided by n fraction, it's still not as good. So for example, adding a node would roughly halve the load on one of the nodes, but like others remain the same. And removing a node would roughly double the load of any one of the nodes, potentially resulting in a hot node. So also not so great. So virtual nodes help to solve those. Now suppose that we have n times l nodes on the ring, and each maps to like one actual like hash value of 1 of n. So for example, hash value 0 can map to like nodes 0, 3, 6, 9. Hash value 1 can map to like 1, 4, 7, etc. And then in this case, we're still gonna remap like similar amount of values, but then like adding and removing hash value would add or remove l nodes roughly, which would mostly map to different hash values and reducing the problems listed. So like for example, we would like get, when we look at it, we get what we get for actual nodes, we would probably gonna get like about similar number of items added or removed. Let's talk about some integration with systems. So the key parameters like current n mapping to the nodes should be stored in a strongly consistent manner, because otherwise like different parts of the system may have like inconsistent view of the state, and it's gonna be a mess. Imagine like putting value into one instance of a cache, for example, and then like another like reader checks and like tries to find it on another instance. That's not gonna go too well. So, and you may want to use some algorithm like Paxos or Raft for achieving this strong consistency in a distributed system. And also depending on your use case, like for example, if it's a cache, then consistency requirements can be relaxed a bit, because in the worst case, you kind of just like start repopulating the cache in a new node, and it's not going to be a big deal if some cache misses happen. Still, it may tank your hit rate to some degree, and it still increases the load on your underlying compute or database several X times, so it still may be undesirable. But for use cases like a database, it can be better to sacrifice even availability instead of consistency. And also there has to be some jobs to move or restore the data if the instance which stores it changes. So yeah, I think that would roughly be it for consistency hashing. I recommend you like drawing some diagrams and experimenting with concrete values of n, m, and l, and just seeing how it is, and like just simulating it a little bit to get a better sense. But yeah, that's an idea. Pretty much you can mention that, like when you need this problem of redistributing like items between instances, you can mention that, hey, we're gonna use consistent hashing, and then like only you need to know some of the details about it. All right, thanks for watching.